Hello everyone, my name is Jyoti Prakash. Today we are going to discuss about the topic comparison between reactive and proactive routing protocols. What are routing protocols? A routing protocol specifies how routers communicate with each other to distribute information that enables them to select routes between any two nodes on a computer network. Routers perform the traffic directing functions on the internet. Data packets are forwarded through the networks of the internet from router to router until they reach their destination computer. Routing algorithms determine the specific choice of route. Each router has a prior knowledge only of the networks attached to it directly. A routing protocol shares this information first among immediate neighbors, then through the network. This way, the routers gain knowledge of the topology of the network. The ability of routing protocols to dynamically adjust to changing conditions such as disable data lines, run computers, and route data around obstructions is what gives the internet its fault tolerance and high availability. Let us go to the introduction. MANET, a mobile ad hoc network, is a collection of mobile nodes that is connected through a wireless medium forming rapidly changing topologies. MANETs are infrastructureless and can be set up anytime, anywhere. We have collected survey of protocol properties of various MANET routing algorithms and analyzed them. MANETs that contain wireless mobile nodes that can freely and dynamically self-organize into arbitrary and temporary ad hoc network topologies. MANET is a collection of communication devices or nodes that wish to communicate with the infrastructure less support and without predetermined organization of available links. In MANET, routing is the main problem to route the data packets from one source node to the destination node in networks. MANET aim is to provide communication capabilities to areas where limited or no predetermined communication infrastructures exist. Types of routing protocols. The routing protocols for MANET considered are classified into two categories. First, proactive, which is table driven. Second, reactive, which is on demand. Proactive routing protocol. Each node in the network has a routing table for the broadcast of the data packets and want to establish connection to the other nodes in the network. These nodes record for all the presented destinations number of hops required to arrive at each destination in the routing table. The routing entry is tagged with a sequence number which is created by the destination node. To retain the stability, each station broadcasts and modifies its routing table from time to time. How many hops are required to arrive at that particular node and which stations are accessible is the result of broadcasting of packets between nodes. Each node that broadcasts data will contain its new sequence number, and for each new route, node contains the following information. How many hops are required to arrive at particular destination node? Generation of new sequence number marked by the destination address. The proactive routing protocols are appropriate for the less number of nodes in networks as they need to update node entries from each and every node in the routing table of every node. It results in more routing overhead problem. There is a consumption of more bandwidth in the routing table. Example of a proactive routing protocol is DSDW, which is also known as Destination Sequenced Distance Vector. Reactive routing protocol. Reactive routing protocol has a lower overhead since routes are determined on demand. It employs the threading concept. Constantly updation of routing tables with the latest route topology is not required in on-demand concept. Reactive protocol searches for the route in on-demand manner and set the link in order to send out and accept the packet from a source node to destination node. Route discovery process is used in on-demand routing by flooding the RREQ route request packets through the network. Examples of reactive routing protocols are dynamic source routing (DSR) and ad hoc on-distance demand vector routing (AODV). Let us go to the DSDV in detail. Destination Sequence Distance Vector Routing Protocol. This DSDVW routing algorithm is based on the idea of classical Bellman-Ford routing algorithm. Routing loop problem is solved which is present in Bellman-Ford algorithm. To solve the routing problem, this routing makes use of sequence numbers. Each mobile node maintains a routing table that includes the number of hops to reach the destination, all available destinations, and the sequence number tagged by the destination node. The sequence number is used to distinguish tail routes from the ones and thus avoid the formation of loops. So, the update is both time-driven and event-driven. A full dump or incremental update technique is used to update the routing table. When the network is relatively stable, incremental updates are sent to avoid extra traffic, and full dump are relatively infrequent. If there is space in the incremental update packet, then those entries may be included whose sequence number has changed. DHDV protocol guarantees loop-free paths and count to infinity problem is reduced in DSDW. Dynamic Source Routing Protocol DSR. DSR uses source routing concept. When packets are flooded by a source node, the sender node catches complete hop-to-hop route to the receiver node. These route lists are caches in a route cache. The data packets carry the source route in the packet header. DSR uses the route discovery process to send the data packets from sender to receiver node for which it does not already know the route. It uses the route discovery process to dynamically determine such a route. In route discovery, DSR works by flooding the data packets in the network with the RREQ packets. RREQ packets are received by every neighbor node and continue this flooding process by the retransmissions of RREQ packets unless it gets its destination or its route cache consists of a route for the destination. Such a node replies to the RREQ with a route reply RREP packet that is routed back to the real source node. Source routing uses RREQ and RREP packets. The RREQ builds up the path traversed across the network. The RREP routes itself back to the source by traversing this path towards the back. The source catches backward route by RREP packets for the upcoming use. If any connection on a source route is wrecked, a route error RRER packet is notified to the source node. Now, AODV, Ad hoc On-Demand Distance Vector Routing. It's one of the very famous ones. AODV uses a very special technique to maintain the routing information. AODV protocol is both on-demand and a table-driven protocol. It adopts flat routing tables, one entry per destination. AODV has multicasting and unicasting router protocol property with an uniform framework. Source node, destination node, and the next hops are addressed using IP addressing. AODV builds routes on a route request or route reply cycle. To determine the freshness of routing information and to prevent routing loops, AODV uses sequence numbers maintained at each destination. Sequence numbers for both destination and source are used. These sequence numbers are carried by all routing packets. Maintenance of timer-based states in each node regarding use of individual routing table entries is an important feature of AODV. If the routing table entry is not used recently, then the routing table entry is expired. When the next hop link breaks, nodes are notified with RERR packets. Each predecessor node forwards the RERR to its own set of predecessors, thus effectively erasing all routes using the broken link. Route error propagation in AODV can be visualized conceptually as a tree whose root is ignored at the point of failure and all sources using the failed link as a leaves. It is loop-free, self-starting, and scales to a large number of mobile nodes. Now let us go to the conclusion, comparison between all of the three. Reactive routing protocol (AODV) performance is best considering its ability to maintain connection by periodic exchange of information which is required for TCP-based traffic. DSR of AODV performs better than DSDV with large number of nodes. Hence, for real-time traffic, AODV is preferred over DSR and DSDV. For less number of nodes and less mobility, DSDV's performance is superior. DSR or AODV is based on route discovery and route maintenance mechanism. Flat routing philosophy is used in DSR, AODV and DSDV. Packet size is uniform for DSDV and AODV. Packet size is non-uniform for DSR. Loop-free protocol property is available to DSR, AODV and DSDV. Thank you.